talk, I will discuss about the different geotechnical centrifuge facilities across the globe and a typical research program related to environmental geotechnics and some of my research experience elsewhere. It initially starts with a Geo-Environmental Engineering overview, then research program and discussion. Nearly 1 year ago, a ship wreckage happened across off the coast of Colombo in the southern part of Indian subcontinent. Okay, there a ship was moving with nitric acid, microplastic nodules, and other substances, and due to a fire in the ship deck, it was totally destroyed, and a lot of toxic substances were mixed with the seawater, and it was washed ashore. And this was the scenario after the ship wreckage. So you can see here, specially dressed people were collecting the waste, and it is kept in the bags across the beach in Colombo. Okay, so this was a kind of natural disaster actually, which polluted the entire beach. Okay, this is one example how a soil pollution happened. Even though it happened in the marine environment, because of the wave action, it moved. It was washed across the beach. This is another scenario you might have seen. This is
Good afternoon, everyone.
Municipal solid waste. This is called landfill site. Okay, even if it is not properly designed,
good afternoon,
there will be leaching of.
So welcome back to the 5-day online faculty development program on advanced soil reclamation techniques.
It will mix up with groundwater,
organized by the Department of Civil Engineering, Muthoot Institute of Technology and Science.
Actually,
before starting the second
Geo-Environmental
session,
Engineering
let me give some instructions to the participants.
Science
so actually, some of the participants have not joined the WhatsApp group which we have created for the effective communication. So please join the group. I can share
there
the
are different
WhatsApp
categories of
invitation link in the chat box.
And all those things, even if it is disposed of,
this is the invitation link. You please join.
It will pollute the environment. And the engineering of
second thing is regarding the feedback
soil, rock, etc.
At the end of each session, we'll be sharing the Google form to
for problems
enter
related
the feedback.
To the protection of human health and environment.
And we will consider your attendance for the FDP from the responses received. And also we'll be
these days
receiving the responses only for 30 minutes.
And rapid development activities.
So at the end of every session, please fill in the feedback form.
Matter of great concern to the engineers as well as the planners.
We'll share the PowerPoint presentation and the recordings of each session with you all.
Containment facilities
and
are
other
designed
learning
and
materials also.
These containment facilities prevent
now,
the
if you have any concern, you please feel
thereby
free to
protect the
contact
environment
us.
if it is in
a
secluded environment. And design, construction and monitoring of the landfill or the mine waste disposal site.
Yeah, good afternoon, sir.
Or barrier system or lagoons for animal waste, etc. Shall I share are also with PPT containment facilities?
Now, I just introduce you after that.
For the remediation purpose, remediation is the process of restoring the land.
So the second session of the faculty development program is handled by Rajeev Kumar P, the professor of Rajgiri School of Engineering and Technology.
Thereby
the topic of discussion is role of geotechnical centrifuge modeling in geo-environmental
restoring the land.
So in order to introduce our speaker, I would like to call Ms. Jarina Jawahar, Assistant Professor Department of Civil
petroleum
Engineering,
contaminated
Muthoot Institute of
beaches and
Technology and
land in the
Science.
Gulf region during the Gulf
Cherinamas,
War. All those areas were reclaimed and
Very good
treated,
afternoon to one and
and
all.
it is now
Welcome back to
reused.
our session today for the Faculty Development Program on Advanced Soil
This is a
Reclamation
photograph
Techniques.
showing the
My duty
geosynthetic clay
is to
liners
invite
widely
our
used
resource person for today's session, who is Mr.
for
Dr.
the
Rajeev
landfill
Kumar P.,
liner system.
Professor and HOD,
Okay.
Department of
Geosynthetic
Civil
clay liner is
Engineering,
nothing but
Rajagiri School of
between
Engineering
the
and
two
Technology,
geosynthetic
Ernakulam, on the topic
materials,
Role of Geotechnical
bentonite or
Centrifuge in Research.
highly
It's my great honor and
impermeable
pleasure
clay soil
to
is
introduce
used.
Dr. Rajeev Kumar P., who has completed
Generally,
his
it is
PhD from
bentonite
IIT
clay
Bombay,
liner.
MTech in
Okay.
Geotechnical Engineering from Region
So, because
Engineering
of
College,
bentonite
Karnataka,
has
BTech in Civil Engineering from Government Engineering College,
nearly
Kottayam. He was a postdoctoral fellow at
10
National
into
Taiwan
10
University
raised to
and
minus
Center for
10
Infrastructure Development,
centimeter per
Yonsei
second
University, Seoul.
permeability.
He
So,
has a
it is
total
mainly
of
used
20
for
years
such
of academic experience, also
clay
dealing
liner
with civil engineering consultancy
work.
works with a
Okay.
number of
So,
professional affiliations and
this is called
publications.
geosynthetic clay
This
liner
was a
or
short
GCL.
introduction
It
to
is
our resource
commonly
person for
known as
today's session.
GCL.
I would like to invite you, sir,
So,
officially
now
for
we will
starting the
see
presentation.
some of
Over to
the
you, sir.
transport mechanisms,
Thank you very
how
much.
the contaminant moves or
Shall I
transport
share
in
the
the
PowerPoint?
geo-environment.
sure, sir.
So transport is nothing but the migration of contaminants through the bio-geochemical zone. And fate is nothing but eventually what happens to the contaminant. Where does it end up? So what happens to it? There are many processes through which it goes. First one may be the mechanical process, second one chemical process, and then biological process. So it depends upon the environment through which, or the
Yes,
geo-environment
sir.
through which it moves in. Shall I start? So you might have seen this picture in.
Thank you very much for the kind introduction.
Mechanics book. Today,
So
there
there
are three phases for the presentation. Solid phase related to geotechnical centrifuge modeling, air. Even though it's so, this is three-phase system. Actually, there is another one, that is microorganisms which are present in the soil. So these microorganisms also contribute to the reclamation or the transport of the contaminant. So there are some examples are this. Some microorganisms like acetobacter and pseudomonas, they contribute to the degradation of the contaminant. Some may nitrify the environment, some may denitrify the environment. This is altogether biodegradation or bioremediation technology. Okay. So here we will see now the distribution of the contaminant in the geo-environment. In general, it may be residing in the pore space in the form of gas. It may be residing in the pore space in the form of solid. Okay, like absorbed or absorbed solid particle from the leachate or even from the chemical species. Okay, so in some cases it may be dissolved in the groundwater itself. Maybe in the pore fluid there may be some contaminant. And in the liquid phase, that is non-aqueous phase liquids like petroleum contamination. In such a case, what happens? Water will remain as it is, and there will be petroleum products along with the water. It may not mix up with water, but in such case, this one is in two-phase system, water as well as petroleum contaminated environment. Okay, these contaminants actually move in the or transport in the geo-environment. I mean water, pore fluid, okay, and even air spaces which are entrapped air, it may be. Okay, it may transport in the geo-environment in the form of mass flow along with the flow of water. So such a mechanism is called advection or advective transport. And the next one is the diffusion. It has two components. One is molecular diffusion. It may move from highly concentrated area to the low concentrated or zero concentration area. It may move with the flowing water, and it may mix up around the sharp edges of the soil particles or even geological formation. okay, in the micro level. And the third one is sorption. I have already mentioned that it may be adsorbed onto the soil particles. Okay, so this adsorption or absorption will retard the movement of the chemical species or the pollutant in general. Okay, so and what happens? There will be partitioning between the gas, liquid, or even solid phase. Okay, there will be due to the chemical reaction. Okay, so and volatilization is another part that is actually from the liquid to gaseous phase, highly contaminated, toxic environment. Okay, reactive contaminants, all those things will move in such a phase. Change in phase from liquid to gaseous phase. Okay, maybe in that process it may be adsorbed onto the soil particles. Okay, these mechanisms happen. These mechanisms happen actually simultaneously. Okay, it may not be a single process. There may be advection, the predominant one. There may be diffusion, the predominant one. There may be sorption, the predominant one. Okay, maybe one or two or even more than that mechanisms happen together. On the other hand, there is a microorganism environment. Okay, these microorganisms actually do the degradation, and there will be biogeochemical activities due to the microorganisms. Okay, you might have heard about bioremediation techniques. Composting is one of the techniques which is commonly known to everybody. So these mechanisms actually depend upon many parameters: soil texture, soil compaction state of compaction of the soil, and the clay content in the geo-environment. There will be ion exchange in the clay media. Okay, there may be the presence of soil organic matter, which will also aggravate the transport or the fate of the contaminant in the geo-environment. The acidity of the soil media, pH value depends upon the pH value. Okay, and then as I mentioned, the cation exchange capacity, it again depends upon the organic matter and clay minerals present in the geo-environment. So all these parameters will directly affect the physical and chemical characteristics of the contaminant. At the same time, the physical and chemical characteristics of contaminant also alter the soil structure and clay content, or even the acidity of the soil, etc. Okay, these are general terms commonly used in the when we talk about the transport processes in the geo-environment. So there are different methods of analysis one can perform in the laboratory, in the field, and for the computer simulation also. In the laboratory experiments, general experiments like all the characterization techniques one should follow before going into a detailed analysis. Okay, basic soil properties in the conventional way you can find out. At the same time, you can go with sophisticated techniques like XRD, XRF, scanning electron micrograph, and inductively coupled plasma analysis. All those things will give the micro structure of the soil which you are dealing with. And there are field tests to find out the contaminant transport. These are monitoring wells. So you might have seen this near the landfill site to assess the leachate movement. Monitoring wells are digged, and these water quality of the wells are assessed timely, and one can easily find out with respect to time how much may be the concentration of the contaminant or the pollutant leaching out from the landfill site, for example. Okay. So this can be adopted in other sites also when someone finds out that engineer finds out that that site is contaminated. So one can assess that whether the pollution concentration is detrimental, or even whether what strategy to be adopted for engineered remediation or constructing an engineered landfill site. Okay. So another one for in the lab which we can adopt was the column test. Conventional way we can do the column test. That's not an expensive one. And batch test with very less samples we can conduct the batch test. And another one which I am talking about in this talk is centrifuge test. Centrifuge test. And there are many softwares available, commercially available softwares are used for modeling and simulation. There are mathematical simulations which you can do, the predictor corrected methods which are already in the numerical methods one might have studied. Okay, so these are some of the commercially available softwares are GeoStudio, okay, Pollute, Migrate, etc. These are the softwares which commonly used these days, and it's freely available also. Okay, now I will show you some of the geotechnical centrifuge facilities across the globe. This one is Sudarshan facility, geotechnical centrifuge facility in IIT Bombay. Now there are small geotechnical centrifuges also available in IIT Bombay. This is from Russell Polytechnic Institute, United States. This one, South Korean one. And you can see this is from University of California, Davis. So this one is the schematic. This photograph shows you some of the instrumentation provided in the geotechnical centrifuge model. Okay, you can see here heavily instrumented one. Again, another photo showing this. This is from University of Alberta. Okay, you may see this one as you can see this video how geotechnical centrifuge, a typical one, moves. You can see here, and one edge you have a swinging bucket. Okay, where you keep the where you can keep the model, okay, which you sample. You can keep. A non-destructive testing method for simulating contaminant transport. I have already mentioned to you. I have given you some intro related to the contaminant transport also. So which can be simulated in the geotechnical centrifuge. Okay, and I have used the small geotechnical centrifuge facility which was available in IIT Bombay for my studies. And finally, I wanted to find out the contaminant transport mechanism which takes place in the soil model. Okay, these two are the soils used for the current study. The soil is a locally available silt, and another one was available kyalinite clay. So, and a combination of both these two were used, and the tool was the geotechnical centrifuge. Geotechnical centrifuge modeling is a kind of testing methodology in which the in-situ stress conditions, like in any is with respect to depth, you know that with respect to depth, the stress conditions increase. We can simulate such scenario in a reduced scale. Say you are taking 1 centimeter by 1 centimeter by 1 centimeter cube, soil cube. Okay. In the geotechnical centrifuge, you can simulate a 1 meter by 1 meter by 1 meter huge soil cube. Okay. Likewise, you can simulate any field conditions like flow through the porous media or even contaminant transport mechanisms, permeability. I mentioned permeability. You can simulate even earthquake conditions were also simulated in the geotechnical centrifuge. Elsewhere in the United States and other places. Okay, So geotechnical centrifuge is a multi-purpose tool where you can even simulate a landslide. Okay, you have seen in one of in the previous video, they were simulating the landslide of the model. Okay, so that is a different possibilities available in the geotechnical centrifuge. Okay, so it is so you can a scale down model can be spin in the geotechnical centrifuge, and it is accelerated to certain gravity level. So 1G level, you get 1G level prototype condition, but if you simulate a model to a higher acceleration level, you can simulate any field conditions. This is what the centrifuge modeling principle is. Okay. In the transport mechanism, the transport of contaminants to the soil mass can be accelerated. Okay, by accelerating the rate of flow, the process can be simulated, and the duration of the testing time can be shortened. Okay, suppose the contaminant transport in a landfill site, if one molecule or particle, we say, so which moves from the landfill site to the groundwater region, suppose it takes 50 years to 100 years. So you can simulate such a condition in the geotechnical centrifuge within seconds or minutes by accelerating the model to a higher level of gravity. Okay, you can see here the prototype condition, that is in situ condition. Okay, you have, as I mentioned, you have a 1 centimeter length soil sample. Okay, so you accelerate in n times of g, maybe 100 times g, you can get a 1 meter high soil medium or a soil matrix. Okay, so this is the way. This is a simple comparison which I have given, and you, by applying the scaling laws, you might have studied in fluid mechanics, Buckingham's pi theorem and all. So this can be applied in this flow problems, and it can be applied in the geotechnical centrifuge modeling also. I will show you in the coming slides some of the derivations which I have done, and it was published in IIT journal. Okay, this is a plan view of the rotating centrifuge, and as you have studied in engineering mechanics, there is a radial acceleration as well as tangential acceleration. We consider only the radial acceleration, that is R omega square is equal to n times g, that is acceleration due to gravity is enhanced to a higher level with n times. Okay, and this tangential acceleration, that is R alpha, is actually not considered because it comes into picture when centrifuge stabilizes. Okay, in the initial part, for a singing bucket type centrifuge, the initial few seconds it will take to stabilize. So we don't consider the tangential acceleration at that time. Okay, so we can calculate the value of n also using this one. Okay, so you can find out the RPM with a specific acceleration level. Okay, so you can find out the RPM of the centrifuge, and you set the speed of the centrifuge to that acceleration with some calibration. You will get the required acceleration level. Maybe 10 times of acceleration due to gravity, maybe 50 times, maybe 100, 200 times. It goes on like that, according to the capacity of the centrifuge. So there are some similitude conditions in the geotechnical modeling, any geotechnical modeling, not only in the geo-environment or contaminant transport. So that is also applied in the geotechnical centrifuge modeling. Okay, so basically there are 3 types of similarities which we consider in a reduced scale model to represent a prototype condition. That is geometric similarity, that is dimension, and kinematic similarity is that velocity and acceleration, and the dynamic similarity. So these similarities will be considered when you do the scaling. Okay, so before you apply the scaling laws, so these conditions will be considered, and you arrive at certain scaling ratios. Okay, So in this, the acceleration is gravity. Acceleration due to gravity is scaled n times. Okay. So whatever you do in the 1G scale, so this can be simulated in a model with n times scale down model. You spin it with that acceleration level, maybe 100 times of g. You can simulate the same condition what you expect in the prototype or in the field condition. Okay, these are the dimensionless numbers one can derive and arrive to simulate the contaminant transport modeling. Okay, these are the dimensionless numbers. If you see the Buckingham's pi theorem, you will understand more on this. This is derived, and it is we have achieved all these things in the modeling front. Okay, so these are dimensionless numbers: concentration, advection, diffusion, capillary rise, dynamic effects, speculate numbers, Reynolds numbers, etc. So these are the summary of this derivation itself is a lengthy process. Okay, so this is a summary of the centrifuge scaling relationship which I have derived, and at the same time there are many other researchers across the globe have done it, and these are the scaling laws or scaling ratios we followed in this simulation of the contaminant transport through the soil. Okay, you can see here general processes. We have sample height. Sample height dimensions are scaled down to n times, that is 1 by n. Okay, so as I mentioned, 100 centimeter height of the soil sample can be simulated in the centrifuge model with 1 centimeter, but the acceleration level is 100 times of g. So this is the kind of beauty of the geotechnical centrifuge. You can simulate such prototype conditions in the centrifuge. Okay, you can even time contaminant transport. Time can be modeled. Okay, so within few seconds you can get maybe 1 year or even 2 years of traveling time of a contaminant in the field. Okay. So these are the dimensionless numbers which I have already mentioned, and the concentration, the density of the contaminant in the field as well as in the model, both are same. And advection ensures the laminar flow again for clay soil, and diffusion again laminar flow. We follow that. Okay. So and the capillary rise can model in both the contaminant transport model as well as in the prototype. And Peclet number actually which denotes the similarity between the model and the prototype. If it is less than 1, and again Reynolds number if it is less than 1, and it's validation of the Darcy's law. These things are already established by research by other researchers across the globe. Okay. So here, the properties of the soil, which I mentioned in this discussion, these are the properties actually for the clay soil. These are the properties, and for the silt, these are the properties. Okay, all these things are done in the geotechnical engineering laboratory, and we have, according to the ASTM and IS standards, we have conducted all these. Okay, you can see the pH value. Okay, one is 8.93, and another one is 6.5, almost the local silt, almost in the neutral state actually. And but here this is slightly on the alkaline side, cryolynite, and 61% of the particles are in the clay region for the cryolynite. And specific surface area, which is actually, you remember I had already mentioned about adsorption or sorption, okay, which retards the movement of the contaminant. If specific surface area is high, the surface area available for the contaminant or the chemical species to adsorb onto the soil is very high, and but for the silt it is very less. Okay, it is, I think it is 7 times less than the clay soil, and this one gives a very less surface area for absorption purpose. These are the values related to the geotechnical centrifuge I used, and you can see here its arm radius is only 40 centimeters, and it has both sides have swinging buckets, and its spin-up time to stabilize it takes 20 seconds, and when you switch off the centrifuge, it takes 80 seconds to come to the stationary state. And its acceleration, that is centrifugation level, is this much, 250 to 1000 RPM, and the maximum G we can get is 300. So these are the centrifuge speeds I am mentioning in this discussion. Okay, you can see here for 50 G you have to spin the centrifuge at an RPM of 426, and for 150 G it should be at 738. So this is the calibration. For every centrifuge has this different calibration levels actually. So for the purpose of finding out the concentration of the contaminant, I have developed a circuit diagram and an instrument. In fact, instrument we have developed, and it is patented, and this is one of the arms. There are 5 channels we have, and one channel is of this type, and they are similar to this. There are 5 different channels. And what happens? It works on Wheaton's bridge principle, and a sine wave oscillator is used for giving an excitation to the bridge network. And when there is a presence of contaminant or chemical species, a particular one, there will be a differential voltage which will be sent back to the data acquisition system, and the computer-based data acquisition system monitors and captures it, and it will be later on analyzed. Okay, so this is the one which we have used, and it is developed, and it is published in ASTM standard as well. Okay, so as I already given you a description of these properties of the soil, and here this one you can see soil samples, typical soil samples we used for this purpose, and it is shown here. Okay, and the acceleration level in the model we have 75 mm model is used in the centrifuge, which simulated a 7.5 meter high prototype condition. And the modeling time, I have already mentioned you, it is n square. The modeling ratio is, scaling ratio is n square, and it is 21.6 minutes. The model which was kept in the geotechnical centrifuge, which created or simulated a time of 150 days, and the modeling time increased to 86.4 minutes. Then the prototype time has been simulated as 600 days. So likewise, you can simulate in the geotechnical centrifuge. Likewise, you can simulate such prototype timing also. This is a photograph showing you the assembly of the sample, as well as the power supply unit and soil contaminant detector, which was developed, and it is under patent. And this is a photograph showing the same, and you can see here the similar thing here, how it moves. Okay, you can see both sides are having swinging buckets. A similar thing happened with the previous setup also. You can see here it moves slowly, it spins up, and then it achieves, stabilizes the required acceleration level. We can set that. That mechanisms are also available. We can set it. Once you keep the sample in the centrifuge box here, and it is closed safely, and there is a stroboscope which can be used for monitoring this. Video camera you can keep on the inspection window. You can keep the video camera. Nowadays, very sophisticated instrumentation systems are used. Okay, you can even simulate rain in the geotechnical centrifuge. You see, it is simulated, and later on, it comes to the, when you switch off, it comes down to the stationary position. That way, you can check whether the centrifuge is working properly or not. the inspection window will give you a picture of what's happening online in the geotechnical centrifuge. Okay. After doing that, I have created 50 times, 75 times, 100 times, and 150 times of acceleration level in the geotechnical centrifuge. This is a typical graph which I am showing here. The S1, S2, S3 are local soil with the different states of compaction and concentration. NaCl is used here, which is actually a passive contaminant. It does not react with the assumption is that it does not react with the chemicals present, if at all it is present in the soil. So we have used this. So chloride ion concentrations are monitored along with the sample length, and this is another one. C1, C2, C3 are the cyalinite clay state of compaction level, and this combination, okay, 40% and 60%. So here these are the concentration levels along the length of the sample, okay, along the length of the sample. And by using these expressions, we found out that Reynolds number and Peclet number. So this is L mu is particle size, Bs is seepage velocity, ρf density of the fluid, and all those things are we have used to simulate or to find out the predominant transport mechanism. It is understood that from the permeability values, these soils will give very low or slow movement of the or migration of the contaminant. So these Peclet number and Reynolds numbers were several orders less than unity. So that was actually an indication that the diffusion is the predominant transport mechanism in the soil samples. Okay, you can see here these are the calculations we have done, and you can see here it is a Reynolds number here 6.8 into 10 raised to minus 9. Okay, and at the same time for D50. Why D10 and D50 are used? Actually, for the barrier systems, these are the particle size we normally adopt for constructing the soil barrier system. And this is on the sideline of centrifuge test. We have done some column tests also. These wire leads are actually connected to the soil contaminant detector, which was developed. I have already mentioned that in the previous slide, and connected to the soil sample. This is a typical soil column, which has a 30 centimeter height and impoundment or the reservoir of around 10 centimeter height. And in some cases, it is less. You can see here, in some cases, the reservoir is very smaller than the height is smaller than the other two, because the leaching of contaminant took place. Depends upon the combination of the soil as well as the voids present in the soil. Okay. So, and with respect to time, the instrument is connected to this and found out the concentration. There is a calibration also with respect to this. You can see here, this is actually typical column experimental results plotted here. And to make sure that the centrifuge modeling is correct, one can go for modeling of model. Okay, different acceleration level, you get almost similar values. It means that your modeling results are correct. This is developed by other researchers also. For this experimentation program, we received a very promising answer. Okay, you can see the higher acceleration level values are slightly away from the other three. Why it is? Because the centrifuge took more time to stabilize in higher acceleration level. In some centrifuges, it can happen. Otherwise, you have to go for 10 times of G or 20 times of G. If you go for 150 G, it's a very high acceleration level. Okay, along with this, I mentioned to you to get the clarity in the experimental results, one can go for computer simulation. These days, very powerful software tools are available in the market, commercially available software. So we have used GeoStudio to simulate such conditions. It is actually GeoStudio is a finite element based software. one need not have to go for basic or even in-depth knowledge in finite elements. Okay, so software takes care of everything. You have to give, you have to simulate such conditions. Yes, hello? 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 Okay, you have to simulate such conditions in the GeoStudio modeling, and you can see here centrifuge results and computed values. We have received a very promising and agreeable answer in this. And these are the glimpses of some of the publications we have done. Nearly 12 papers were published from this work, along with a monogram. Okay, this is the one, and it has only very less price. Okay, if one is interested in, can be purchased. Okay, so these are the concluding remarks from the discussion so far. Geo-environmental engineering as a whole is a multidisciplinary subject. These days, sustainable geotechniques are coming up. Sustainable geotechniques, forensic geotechniques, all these topics are the hotcakes these days. But still, the environmental problems are very creepy, and it is very much in front of us. Okay, so people are interested in geo-environmental engineering problems. So it comes with civil engineering, chemical, electronics, computer simulation, microbiology. The bioremediation techniques are very much used while I did postdoctoral work in Taiwan. My work was related to bioremediation of aromatic hydrocarbon contaminated soils. Okay, so it requires sophisticated instruments to monitor the microorganisms, the work, the influence of microorganisms on specific chemicals. Okay, so basic knowledge of all these mechanisms are required for a desirable research program. Okay, so modern tools are there which can also be used. So this work gave me PhD, and at the same time a national award from IST in 2007. I am a KTU's PhD guide. If one of you, or if anybody is interested in doing PhD work, you can contact me. Rajagiri is one of the research centers of KTU. You can get more information about my work from these websites. I have a YouTube channel also. You can visit that also if interested in. I think thank you very much from my side. If there is any question, you can ask me.